So here we go. I am going to generate. All right, desk number 5. Anybody at 5? Nobody at 5? Desk 14.
Number 1?
Yes, number 1, Nick.
Potassium chloride.
Potassium chloride. All right. Number 2, Li2O, desk number 11. Lithium oxide. CaBr2 goes to desk number 7. Anybody there? No.
Yeah, I wanted those.
Desk number 23. Calcium what? Bromide. Calcium bromide. All right, now we have to come up with the formula. So desk number 15. K3P. Desk number 27. What is the formula for calcium fluoride? Did you do sodium nitride? No. You didn't do it. Tyler.
Number 4?
Calcium fluoride.
Oh, that's CaF2.
CaF2. Desk number 19.
Na3N.
Na3N. Desk number 20.
Oh.
20.
What number is it?
7.
MgCl2.
MgCl2. And desk number oh gosh, let's go with 5. No, nobody's at 5. Desk number 29. CaCl2. Okay. So that is what we did yesterday.
Is today hard?
So what we're doing today,
I just don't want it to get hard.
so I need you guys to answer some questions for me before we go to today's. So yesterday we talked about what made up our compounds. What were our rules? It's ionic. And then the first rule was to, after we name metal. And then the second rule was to
Name the non-metal and add ion.
so name the non-metal and change the ending to "ide." So that was, yes, make it fast. That was,
Sorry.
you guys got to focus. That was yesterday. Today, where were all those metals located?
On the left.
On the left. And so that means that was group 1, 2, and we dealt with some in group 3, right?
Yeah.
The ones in group 3 that we looked at were boron and aluminum. Those 2 groups and boron and aluminum will never change their charge. So I would write that somewhere, that those will never change the charge.
Just boron and aluminum.
And what group 1, 2, and then group 3, boron and aluminum.
They'll never change their charge?
Their charge. They'll never change their charge. Calcium will always be +2. Aluminum will always be +3. Those are metals. For our non-metals, when we're talking about ionic compounds, never change their charge. Oxygen, when it's an ionic compound, is always -2. Bromine is always -1. They will never change. So that leaves me with this big area on the periodic table. That big rectangular area is what?
D block.
The D block. And then we have this little area underneath the staircase that we classify as other metals. So our transition and our other metals will change their charge. Because they can shift their electrons into different orbitals because they have the larger orbitals out there. They have that d orbital. So you have to be able to figure out what that charge is. Okay, so in front of you, take out a blue card and take out a pink card. Electron's charge is always negative. Location or the speed. Okay. What I need you to do. What I need you to do is the following. I need you guys to look at the blue card, look at the pink card, look at the formulas on both, look at the names. Find the similarities, find the differences in the names. That's a Roman numeral. When you get to what I need you to do next is tell me, what do those Roman numerals on the blue cards represent?
Blue. Wait.
And then,
Blue.
what new rule do we need to add to our additional rules? So tonight's homework is going to be, if you go down to the bottom, it says transition and other metals, 1 through 20. That will be your homework. Please mark out the following: 9, 10, and 14. Okay? So I'm kind of actually going to just fly through this. We're going to just kind of go ahead and take a look at this now together. So take a look at those cards. So what is similar and what is different? What's similar between the pink and the blue? So they both end in "-ide. What else? They both consist of what?
2 elements.
What type of elements? Metal and non-metal. What's different about them?
There's like a 2 on the rules.
A 2?
Yeah, like an II.
That's called a Roman numeral.
Alright, it's got Roman numerals.
So they have Roman numerals on the blue ones. If you look at the element combinations, we still have subscripts there, okay? And those subscripts still represent the number of atoms that are there. So nothing's really different about them. But the Roman numerals, if I have, say, CuCl, and I have CuCl2, they're in different ratios, right? Okay. So, since they're in different ratios, I need to be able to tell these guys apart. I need to be able to tell. I know they're both copper chlorides, but I need to know which type of copper are we talking about. So looking at that, which element's charge will never change?
Chloride.
Chlorine. Chlorine will never change its charge. So in both cases, chlorine's charge is what?
Negative
-1
Negative 1. I was looking at the wrong.
and -1. We have a 1-to-1 ratio, copper to chlorine. We have a chlorine with a -1 charge. What charge does copper have to be to negate that -1? It has to be a +1. Oh, a +1. So if you go to copper or CuCl2, I have a 1-to-2 ratio. So I'd have a charge of -1 on the chlorine, and I have 2 of those. So what does the charge of copper have to be to negate that -2 charge?
2.
+2. Okay, so in the name, I have to be able to determine, I have to be able to show these charges. And so how am I showing those charges in that name? In the Roman numeral.
Oh, so it would be like
How many Roman numerals could you have? Like the charge has -7.
Sometimes you'll go up to 7, a +7. Charge of so the Roman numeral represents the charge of the transition or other metal. I will sit here and I will ask you, what's the charge of copper? And you'll look up at the periodic table and you'll sit there and look and look and look, and the periodic table is not going to tell you the charge of copper. The periodic table is not going to tell you the charge of lead or zinc or any of those. We have to look at the formula or the name. So what is our new rule? So the first thing we're going to do is name the metal. That does not change.
all right.
Name the metal first. After we've named the metal, now we've got to put something new in there. So we are going to write the charge as a Roman numeral. If you do not know your Roman numerals, then please go back and refresh on that, at least to 10.
I thought it was tally marks this whole time. I don't know how to do Roman numerals.
And put parentheses around them.
I'm so disappointed.
And lastly, so we've got our name, metal name, and we've got our Roman numeral representing our charge. So our last rule, what we need to do is we need to name the nonmetal and do what?
Add I.
Change the ending to IDE. Okay? So the next thing I need you to know is I need you to look here at my periodic table behind my desk. And there are, so this is what we're centered on. These are the ones that will change their charges, okay? All these right here, too, will change their charges. But what I need you to do now is that there are 3 exceptions that I expect you to memorize. You need to know that zinc and cadmium, they're right under each other. They will always be a positive 2. And how do I remember that? I go and I see what column they're in. They are in column 12. I cover it up. Oh, that's its charge too. Silver will always be 1. So I go and I see what column it's in. 11. I cover up the first one, and that is its charge. So I just remember that these, right here, will never change. 2's, 1. Since those charges will never change, when you write the formula for, or write the name of the formula, you would write zinc chloride. The 2, the Roman numeral does not need to be there. Why does the Roman numeral not need to be there? Because it never changes. Just like the reason why we don't put Roman numerals in the group 1, group 2, and boron and aluminum. It is assumed that you know that that will never change. Okay? So is there any questions on that before we start practicing them?
So they never change, you don't split it, but if they do change.
Yes.
Okay, so it's just those 2 or is it that plus
Those 3. Zinc, cadmium, and silver. Okay. Let's practice naming. So we know we are naming, and we know that they're transition metals. So the first thing I'm going to do is I'm going to name. I'm not going to worry about the charge just yet. I'm going to name my 2 elements. Cu is what? Copper. Copper is a transition element. It's not one of our special ones. So that means it needs to have parentheses after its name. O is what? Oxygen changed to oxide. So we've got the backbone of our name. We just now need to know what the charge. What copper are you talking about? Are you talking about copper 1 or are you talking about copper 2? So we know whose charge will never change?
Oxygen.
Oxygen. Our non-metal's charge will never change. So oxygen is a -1, or -2, sorry. -2. And we have one of them. So what does the charge of copper have to be to negate, if it's a 1-to-1 ratio, what does it have to be to negate that -2? It has to be a +2.
All right.
Does it ever have to, like, can the Roman numeral ever be, like, negative?
No, Roman numeral will never be negative. Mn. What is Mn? Manganese. Is manganese one of the special ones?
Nope.
No. So it needs Roman numerals. And what's Br? Bromine. So it becomes bromide. Bromide is always a -1. We have a 1-to-1 ratio. All right, 1-to-1 ratio. So what does manganese have to be to negate that -1? A +1.
Where's PB?
89, I think. No, that's 82.
So it's basically just moving what it should be into the.
All right, PB is what? Lead. Thank you for not being so cheesy and saying peanut butter. I don't know how many times I heard that today.
That was gross. Tyler said that. What a dweeb. I like that.
No longer my favorite student.
It's been a while.
So what is lead one of our special ones?
Nothing I can see.
No.
I haven't even looked at a periodic table.
And F is what? Fluoride. What is the charge of lead? What's the charge of fluorine? Fluorine never changes. Its charge is what? -1. We have a 1 to 2 ratio. So what does the charge of PB have to be to negate this total of -2? +2. CO2O3. CO is what?
Cobalt.
Cobalt. Is it one of our special ones?
No.
No. O is what? Oxide. What's the charge of oxygen? -2. We have a 2 to 3 ratio. So what does cobalt's charge have to be to negate this -6? This times this is -6. So what do I have to multiply this 2 by to get to a +6? A 3. So that means we get 3 tick marks in here.
I don't understand. It's okay. Because then isn't 4 like the I and then the V behind it? You have to like subtract.
And lastly, what's the name of this one? This is ZnCl2. Zinc
Yeah, you can.
chloride. Do we put the Roman numerals in there? No. Why not?
Zinc is always +2.
Because zinc is always +2.
So you kind of only need to worry about cadmium and silicon.
Yes. Okay. So look here. We have PbO2. So tell me, what's the charge of lead in each one of these?
Well, that one's gonna be a +2, and that one's gonna be a positive. No, actually, I lost.
Which one's +4?
Oh,
PB what? Which one's +4?
the right one.
The right one. The right one is a +4. The left one is what?
Oh, +2.
A +2. How did we figure that out?
Because you have to do the charge of oxygen is -2, and then you multiply by that.
Charge of oxygen is -2. And we have to look at those ratios to determine what the charge of lead is. Okay? I will tell you that lead and tin, SN, are the big ones that have that. It could be 2 or 4. So, I don't know. All right. So let's write some formulas. So Miss White here is, I don't know what was going on here, but it is not sin. It is tin. Tin for oxide. So the very first thing I'm going to do is I'm going to write the elements.
Is this from yesterday? Or no?
What is the charge of tin? How do we know it's +4? Because of the Roman numeral. What is the charge of oxygen? -2. So how many oxygens do I need to negate that positive 4?
You need 2 of them.
2. So my formula is what?
SNO2.
No.
SNO2.
Sorry, I had a second.
She's like, no.
I had a second where I was
Lead 2 sulfide. What's the charge on lead? +2. What's the charge on sulfur? -2. So my formula is PBS.
If it's like perfect, there's no exponents, but if we add 2 or subtract 2, there is exponents to what we add or subtract. Like where we put 2 on oxygen, it goes into with oxygen.
So this is -2. We're multiplying.
That's 7.
So, right, you have to multiply to get the overall charges to negate each other. Okay? So let's look at manganese 7 oxide. Manganese, what's the charge of manganese?
It's 7.
It is a 7. Oxide is -2. Do these negate each other if it's a 1-to-1 ratio? No. What does the ratio have to be so that the charges will negate each other, will cross each other out? What's the common number between them?
14.
14. And I need a -14. So manganese, how many do I need of it?
2.
2. And how many do I need of oxygen? 7. So my formula is Mn2O7. Yes, it's the same thing that applied from yesterday. You're trying to find it. Yeah, I will go, hey, what's the charge of iron here? And you'll look at the periodic table and you'll go, 8, because it's in column 8? No. It tells you what the charge is. Okay? So here, the charge of iron is what?
3.
What's the charge of fluorine?
-1.
So what's the formula? FeF3. And lastly, silver chloride. Silver is Ag. Chlorine is -1. So the formula is AgCl. Is there any questions on that? So like I said, your homework tonight is 1 through 20 in that third part, transition and other metals, with the exceptions of 9, 10, and 14. And I'm going to come by and I'm going to stamp your homework.